So I don't get many views on my videos. And every once in a while I get the thumbs down. Somebody hits the thumbs down button. And I figure they don't like what I'm saying, or maybe they don't like my accordion or my picture of Jesus at the last brunch. But anyway, I get the thumbs down once in a while. And I'm thinking if it's because of the content or my ideas themselves, then maybe I'm not making myself clear, or maybe they just don't want to hear it. So I'd like to review a couple things here and cover two really major points in my discussion on electrical service, okay? So I'd like to review some stuff and then make those two major points again, and I hope that I do it very clearly and concisely, all right? So to make those two major points that I want to review, I used graphic representations. The drawings are primitive and I did them by hand, but I think they get the job done. I used the generator graph, I call it, just a picture of a generator or a generator symbol, right? That's kind of actual or practical. In other words, a generator is a real thing. The rotor spins inside, and then it's right beside the armature windings, and et cetera, et cetera. Okay, so you know that's a generator, all right? Then I have the cycle graph, and this is the one cycle, all right, that's created when the rotor revolves one time around, all right, inside the generator. In other words, the rotor rotates inside, right inside the armature windings like this. And when it goes around one time, okay, one circle or one cycle, right, then you graphically get this. But this is theoretical. This is not actual or practical. This is theoretical, all right? I want to make that clear for later. So you have your generator, and cycle and circle come from the same word. So you get one full rotation, one circle, one cycle. You can imagine in your mind theoretically that cycle on your cycle graph. I talked about that, right? And then I showed primitive pictures of transformers. This is what I call a transformer or a coil graph. I showed that. We'll talk about that in a minute. Then I have a panel graph, a very simple drawing of a service entrance panel, your panel graphs. And then again, your transformer or coil graph, and then your send return graph, I call it. It's just lines showing directions of current flow. Okay, so that's the graphic representation that I've given you, and that's how we get an understanding of my ideas, my new ideas and new terms. Now, one of the key points so far is this. I call the service single cycle service, not single phase. And to get to my key point number one, which is the naming of the process single cycle, is the fact that over the many years, almost 140 years, electricians and professionals and engineers have actually blended the actual or practical with the theoretical. And that's how they got their terms. They got their terms by blending the actual and the practical. And over time, that gets confusing. When I presented all my music ideas on YouTube, I explained clearly that the same thing happened in music theory over hundreds of years. The actual and the practical came together and jumbled everything up. For example, with scales, they took scale theory and mode theory and tried to kind of combine them, and it made a jumbled up mess. I pulled that mess apart and I cleaned it up thoroughly, and that's what I'm trying to do with electrical. So you see here, you have one cycle, on your cycle graph. This is not that complicated, but within each cycle, you have two phases. You have phase A, current goes this way, and phase B, current goes that way. This is theoretical. This graph is showing simply that current flows one way and then the other. Now, a phase, an actual phase, by definition, okay, let's look at this. A phase is a distinguishable part in a course or cycle. Even the word cycle is in the definition. A phase is a distinguishable part in a course or cycle. So you see here that you have two phases in one cycle. And why or how on God's earth it came to be called single phase doesn't make any sense. There are two phases inherent in each cycle. So initially, it would have been more sensible for them to call it dual phase or double cycle or, double phase or two phase. This is theoretical, but it gives you mentally a very good idea of what you're dealing with, okay? So you see then the first key major point that I'm bringing back up in this video. The key point is the single cycle service gives you one cycle in 1/60th of a second, all right? The phase, each phase is a distinguishable part. They're different, each is different in the one cycle. So the key point then is the phase is not the thing itself. When they say single phase, the phase is not the thing. The phase is a part of the thing, which is a cycle. The phase is not the noun, the thing. It is a part of the thing, and the thing is a cycle. It is single cycle. I'll probably get a lot of nasty energy coming my way for saying this, but this is an actual fact. Even though what I'm showing you is theoretical, inside the actual generator, what I'm telling you is happening. You kind of can't dispute it. All right, let's move toward the second major point. On your transformer or coil graph, whatever you want to call it, right? You'll see this on the internet all over the place. There are thousands and thousands of electrical videos, and you'll see something similar to this. Very simple, very primitive, right? And you'll see what they call line 1, and you'll see what they call line 2, and you'll see this center tap here. You'll see a conductor coming out, and it's called a neutral. I call it a median. I've changed the term. I call it a median because neutral, like some of these other terms, just doesn't make any sense. It's stupid, right? So you'll see this. But here is the second key major point, and this is probably what really annoys people in my electrical videos. This graph here, all right, this coil graph or transformer graph is kind of an illusion. It's kind of an illusion because the coil, this thing here, in actuality, in other words, in actual or practical as opposed to theory, all right, is really this. It's really just one conductor. It's just a coil. It's the secondary coil in the transformer up on the utility pole somewhere near your home. Now, a lot of times, especially where I live here, transformers are shared by many homes, several homes, okay? But in there, in that secondary coil, all right, it's just one coil. And I'm thinking, oh, one coil, single cycle, all right? Because we imagine this because this is what we're told. We look up there on that pole, we see a transformer, and we see 3 conductors coming out. So we think we can have multiple items here. No, all you have is an illusion. You have one coil here. What you have is reference points. You have the end of this coil and you have the other end of this coil. And somebody decided, well, you know what? Let's stick something here right in the middle of that coil. We'll call it a neutral. I call it a median, but let's call it a neutral, right? So really what you have is just one conductor. It's an illusion. This is the illusion. This is what we kind of try to see with our eyes on the utility pole, or we try to see it inside the service entrance panel. We think, oh, line 1, line 2, there's your neutral bar, blah, 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 right? But over here, we get to the illusion part. This is even an illusion, because on your transformer or coil graph, what you have is just reference points. This is the end of the coil, and this is the other end. And magically, somehow, they become lines. That's what they're called, lines. This is your live line. They call it hot, which is a crappy term. Live, number 1. Live, number 2. And over here, you see, if you put that neutral on the center tap, and I call it a median, all right? If you do that, you have a leg here. You have a leg, but you still have, it's a pathway. You still have the end of your coil. Theoretically, you see, theoretically, it's just the end of the coil, right? And then phase A, you see phase A, current goes one way on one conductor, one coil, and you see phase B, current goes the other way. This does not happen simultaneously. It's one, then the other, then the other, then the other. That's how it really is. This is kind of an illusion. My 2 key points. It is single cycle service in your home. You can call it phase if you want to. You continue. So somebody can say, you know what, that's stupid. That's radical. I'm never going to present that to the National Electrical Code. I'm not going to do it. But that's okay, because I'm telling you, when you go from the actual to the theoretical and you go back and forth, you end up with single cycle service. Or if you're doing what you call 3-phase, which is a horrible term, it's actually triple cycle service. So those are the 2 key points, and I hope it didn't take too long. But don't give me the thumbs down. Don't be a coward. You don't have to put your name in there, but at least put a comment and say, Joey, I disagree, and I'll tell you why. Just don't hide behind your mommy's skirt. Say something, or just don't press the button at all. It's not productive. It's infantile. It's like my neighborhood here. I'll tell you about that in another video, about the behavior and the anger and all the negativity. But for now, I'm being positive when I present this because I'm pretty sure that I'm onto something. So thanks for being incredibly patient, and thanks for not giving me the thumbs down. Later.